So if you do not have a piece of paper and your pencil, make sure you pause the video, go get that, and then come back, because the way we learn is through practice. Today we're going to talk about equivalent ratios. An equivalent ratio, well, what does equivalent mean? It just means that they are going to equal each other. Your ratio is going to be your fractions, your parts to the whole, and it's obtained by multiplying or dividing the numerator and the denominator by a ratio by the same number. Goodness, excuse me. Okay, so for instance, if I have a cake, half of it's chocolate and half of it is vanilla. Right now, if I ask for the chocolate, you would say it's 1/2. But if I make another cut into it, what do I have now? I have 2 chocolates out of 4. Well, how did that happen? Well, I just made it 2 times greater. Well, I didn't just make the chocolate 2 times greater. I made all of it 2 times greater. That's why I would have to multiply the numerator and the denominator by 2 to get it. And then if I had a bunch of cuts in it and I took away some cuts or erased some lines and I made it smaller, then I would be making it like this right here. If it was 2/4 and I took it down to, I erased this one line and I took it down to 1/2, well, what did I do? I had to divide it by 2. Well, if I did that, if I made it 2 times less, I would do it to both because it affects both of them. And that's all we're doing today. We're finding equivalent ratios. We are finding what the other ratio is, but it equals the same value as the other one. So complete the statement, 7/12 equals blank 48. Well, if I have 12 pieces of something and I increase it to 48, well, remember, if I'm increasing it, I would multiply. What did I multiply by 12 to get 48? 4. I made it 4 times greater. So I need to make my numerator 4 times greater as well. And 7 times 4 is going to be 28. Okay, how did you get from one side to the other? Well, I multiplied. You can only multiply or divide when you are finding equivalent fractions, ratios, anything like that. So let's go down to our examples. I need these to be balanced. I need these to equal the same thing. Well, right now, this is out of 20 pieces and this is out of 4 pieces. How do I turn my 4 into a 20? 4 goes into 20. That's why I'm wanting to turn it to a 20. So what did I have to do to that 4 to equal a 20? Well, I multiplied it by 5. 4 times 5 is 20. If 4 times 5 equals 20, I made that 5 times greater. What am I going to do my numerator? Also make it 5 times greater. So 3 times 5 is 15. If they are equivalent, if they equal the same thing, then my number right here should be exactly the same thing. So what is my missing number? My missing number is 15. And I didn't have to rewrite it down here. I was just showing you. 4 times 5 is 20. 3 times 5 would equal 15. I just wanted to show you what was happening. I'm trying to get the exact same fraction. And that happens when I multiply or divide in other ones. Here, I have 48. I can't really go, yeah, I can. Well, I can't really go from right to left and increase it because I don't know what this number is. I don't know what I'm going to multiply it by. So let's go the other way. 48 divided by what is going to give me 8? Well, if I divide it by 6, it's going to equal 8. So I'm just going to rewrite this fraction. So I'm trying to figure out, and let's not use the question mark. Let's go ahead and just use a variable. And I'm going to use the n for a number I don't know. Makes me feel like I'm in middle school if I'm actually using variables. Well, if I made this 6 times less, I need to make this 6 times less. And 54, if I take my 54 and I divide it by 6, I am going to equal 9. So if my fraction now is 8/9 and these are exactly the same, I know that my n is also going to equal 9. And again, I didn't have to rewrite it. I'm just showing you what is happening. I'm trying to make these the exact same fraction. So 48 divided by 6, 8. 54 divided by 6 would have just been 9. So that's really the math that's going behind it. On this next one, I am going to show you the cross multiplication because it's this, you're doing the same thing. You're trying to find a common denominator and you're making your ratios equivalent. And since we just did a lesson on this, we're going to just go ahead and start doing the butterfly method. Instead of having my question mark, I'm going to put my variable n. Remember, I start with my, we call it butterfly method. We start with the wing with the variable. 20 times n is going to give me 20n. 35 times 4 is going to give me 140. Multiply, and then I divide because I want n by itself. So what's with the n? 20. So I'm going to divide it by 20. Whatever I do to one side, I do the other because remember, this is a balance. They have to equal the same thing. And if I just just made this 20 times less, I need to make this 20 times less as well. That would leave me 20 divided by 20 is 1 times n, which is just n. And then if I have 140 divided by 20, that is going to give me 7. And then I can check. Let's just go back. So I had 20 over 35, and I had 4 over the question mark, n. Well, what did I do to this 20 to get to 4? I had to divide it by 5. 20 divided by 5 is 4. Whatever I do in my numerator, it also affects my denominator. So 35 divided by 5, that's going to equal 7. Exactly what I got down here. You choose the method that's best for you. I'm going to continue with the cross multiplication. Number 4. I'm going to start with my wing that has my variable. 2 times n, 2n. 5 times 12, 60. Multiply, and then divide. I'm going to divide it by whatever numbers with my numerator. Whatever numbers with my n. Divide the other side, 60 by 2 as well, because whatever I do to one side, I do the other, since they are equivalent, and I'm trying to keep it balanced. 2 divided by 2, it's going to give me 1. 1 times n, n. 60 divided by 2 is going to give me 30. And that is my answer. And then I can just check. 2 times 6 would have given me 12. 5 times 6 would give me 30. And that's exactly what I got. Do the one with my variable. N times 1, n. 13 times 4. Whoa. Using my calculator. 52, multiply, but oh, look. What's with my n? Nothing. So I don't have to divide. That is my answer. And I can check. 1 times what equals 13? Well, times 13. So if I multiplied this by 13, I would have to multiply my 4 by 13. 4 times 13, 52. Number 6. Do the one with variable first. 7 times n, 7n. Whoops. 14 times 4, 56. Multiply, and divide. Divide by whatever numbers with your n. There's a 7 with my n. I do it to both sides to keep it balanced. 7 divided by 7 is 1, leaves me just the n. 1 times n. 56 divided by 7, 8. And I can check. 7 times 2 is going to give me 14. 4 times 2 is going to give me 8. Okay, I want you to do 7, 8, and 9, pause it, and then check your answers with me. Okay, first of all, I'm in middle school, so I'm going to change that to a variable. 8 times n, 8n. 5 times 64 is going to give me 320. Now, I did my multiply, now I do my divide. Divide by whatever number's with your n. There's an 8 with my n, so I'm going to divide both sides by 8. It's going to leave me with 40. 320 divided by 8 is going to be 40. And then I can check. 8 times 8, 64. 5 times 8, 40. Start with the 1 with the variable. 3 times n, 3n. 21 times 1, 21. Divide it by 3, because there's a 3 with my n, and I want to get rid of my 3. 3 divided by 3, 1. 1 times n, n. 21 divided by 3, 7. All right, number 9. Ooh. 32 times n is 32n. 72 times 4 is going to give me, 72 times 4 is going to give me 288. Divide by 32, because that is what is with my n. I do the same thing to the other side because I want to keep it balanced. And when I divide it by 32, n is going to be 9. Why can you multiply or divide both terms of a ratio by the same number without changing the value? Because I think we proved up here, when you either separate them or put them together, it affects both parts that you're talking about. So it either makes them both greater by the same amount, or it makes them less by the same amount. All right, we are going to move to ratios with equivalent ratios in our word problems. So example 1, at summer camp, the ratio of boys to girls was 7:2. If there were 21 boys, how many girls were there? Okay, I will tell you the biggest thing that you need to make sure you pay attention to is label your ratios. Now, in the last lesson, we learned different ways to write ratios. One of the ways we could write it is like this. Another way was to write it as a fraction. So right now, if it says boys, 2 girls, that 2 means you're going to do a colon. So this is 7 boys to 2 girls. This is where write it boys over girls. And then you have 7 over 2. Whether you want to put them in parentheses, something so you know that this 7 is the boys and you know that the 2 is the girls. And equivalent ratios. I want the same ratio between my 2 numbers. Now remember, you have to, if I started with boys on top, I have to have boys on top on the other side. So if there were 21 boys, that my boys are in my numerator. How many girls? Oh, I'm looking for my girls, so I'm going to put my n for a number I don't know. That's what I'm looking for. And now it's in a format that's easy, that I'm familiar with, that I've been practicing. 7 times n, 7n. 21 times 2, 42. And then I divide both sides by 7. Leaves me with n equals 6. So how many girls were there? If there were 21 boys, then there in the group, then there would be 6 girls. That is the same ratio. So 6 girls. And you don't have to include N in your answer. Your answer is there are 6 girls. Has the same ratio. Example 2. In a basket, there are 24 good oranges and the rest are bad. The ratio of good oranges to bad oranges is 3-1. Okay, so if it lists the good oranges first, so I'm going to put good, bad, since they're both oranges. If it lists the good oranges first, then that will be your first number. You have 3. 2, remember that's your colon, and the bad is going to be 1. So it's 3-1. You want an equivalent. You want the same ratio, just with different numbers. So if there are 24 good oranges, well, where are we writing good? We're writing them in the numerator. See how much easier it is if you've labeled it? It's easy to find where they go. So how many bad oranges? So we're looking for bad. This is a number I don't know. And then all I do is do my cross multiplication. 3 times n, 3n. 1 times 24, 24. And remember, I'm solving for n, so I need to get rid of my 3. 3 divided by 3, and I want to keep it balanced. I want them to stay equivalent, so I'm going to divide the other side by 3. 3 divided by 3 is 1. 1 times n, just n. 24 divided by the 3 is going to give you 8. So how many? I have 8 bad oranges. You mean my answer is not just 8? No, these are word problems. You should have units behind it. I don't have to include my N in my box. Example 3. In a play, there are 16 red balls and the rest are white balls. Okay? The ratio of red to white, so I have red, 2, remember that 2 means colon, white balls, is 4-5. So I'm going to write red to white. Red's written first, so it's going to be my numerator. Red's written first, so my first number is going to be the red ones. My second number, since white balls is written second, is going to be my second number. So when I rewrite this ratio, I'm going to write as a fraction. Red balls to white balls. And I know that I am keeping it equivalent. Again, make sure you always label it. It's so much easier to not mess it up, to keep yourself straight, to have success. So it tells me there are 16 red balls. So where's my red balls? Oh, it's in the numerator, it's on top. And the rest are white. Well, I don't know. So it's a number I don't know. I'm going to use n for a variable because that's what I like. I like my n. Okay, multiply it. 4 times n, 4n. 16 times 5 is going to give me 80. And then multiply, and then divide. Remember, I want to get n by itself, so I have to divide it. Since it's being multiplied 4 times n, how do I get rid of that? I do the inverse operation, and the inverse operation of multiplication is division. That's why I'm dividing. Divide by the same number, so it will give me a 1. Do it to both sides because I want to keep them equivalent. So 4 divided by 4, 1. 1 times n, n. And then 80 divided by 4 is 20. So how many white balls are in the play? There are 20 white balls in the play. Okay, right now I want you to pause it. I want you to do 4, 5, and 6. Unpause and check your answers with me. The ratio of the left-handed pitchers to, there's the word to, they're comparing to the right-handed pitchers on a baseball team is 2-5. So I have right, no, I have left written first, left. And then I have right. Okay, so if left-handed is listed first, then that is going to be the number 2. Whatever number's written first is going to be my first, it's going to be my numerator. And then to 5, 2 to 5. And this is going to equal the other ratio. So let's see. If the team has a total of 14 pitchers, if the team has 14 total pitchers, how many are left-handed? Okay, so now I have this listed as left to right. So we have to think about, okay, well, since it says total, this isn't the total. This is left and right. I cannot put 14 down there. So I know that this ratio is not going to work. So I'm going to cross it off. And then I'm going to have to rethink about this. So now it says, if the team has 14 total, how many are left? Okay, so I'm saying total to left-handed. Well, how many total? Okay, so how many total pitchers are there? Well, I know 2 are left and 5 are 7. So isn't that going to give me, 2 left-handed and 5 right-handed. So isn't that going to be a total of 7? Right? The total. And then how many is left-handed? 2 are left-handed because it was written first. So my number that's written first, that will be the same thing. So there's 2 left-handed pitchers to a total of 7. I apologize if you did this on your own. I'm sure you struggled with this, but this is good because hopefully you caught yourself like I did and went, oh, wait a second. It says total. It was a good thing I labeled those because neither one says total. So now I need to, how many? Okay, so if the team has 14 total pitchers, so I know I'm doing 14, how many are left? Well, I don't know that number. So do my cross multiplication, 7 times n, 7n. 2 times 14, 28. Divide both sides by 7, and that will leave me n equals 4. So how many are left-handed? There are 4 left-handed pitchers. Nice. I love those. All right. A survey at school found the ratio of students who use a pen to do their math homework to, so you'll see that they're comparing, to students who use a pencil is 2 to 7. How many of the 45 students surveyed use a pen to do their math work? Okay, well, all of a sudden it's telling me how many that are surveyed. Isn't that giving me a total? So I'm doing a total to pen. So total to pen. Oh no, kids are coming back. So my total, how many totals? 2 plus 7? 9. How many use a pen? 2. Oh no, I put those wrong. So now equals, and then it says how many if you have 45 students. Well, if I have 45, I got the 9 by seeing they said 2 use a pen and 7 use pencil. So I just added those together. That's how I got the 9 total. Now I'm turning it into, I'm not going to do the by far method. I'm going to just do this. 9 times what equals 45? 5. Multiply that by 5 as well, and you get 10. So 10 students use a pen to do their homework. Oh, If the basketball team has a ratio of 3-2 losses, if they play 20 games, how many did they win? This is the same way. You're going, if they play 20, so they need a total. What's the total between the two? 5. Here's the total. And then it says, how many did they win? So you want to know when. So 5, and what's the wins? Wait, just a second. Okay, and so the wins says 3 wins to 2 losses. So the wins are 3. So if they play a total of 20, I'm trying to figure out how many they won. So 5 times 4, it's going to give me 20. 3 times 4. So how many did they win? They won 12. All right.